Cosmos vision came out of really trying to understand wireless technology from an end-to-end perspective. This has always been one of the hallmarks of research at NYU Wireless, where we have a range of talents from people who understand the fundamental propagation and circuits, all the way up to the devices and applications that run on wireless networks. Cosmos stands for Cloud Enhanced Open Software Defined Mobile Wireless Testbed. Is one of two testbeds that was awarded as part of the Platforms for Advanced Wireless Research, or PAWR. PAWR is funded by the National Science Foundation and the industrial affiliates of the PAWR program. The project is led by Rutgers WinLab, along with Columbia University, and NYU is responsible for the millimeter wave components. NYU Wireless's participation in Cosmos comes after more than 5 years of pioneering work in the area of millimeter wave communication. About 5 years ago, the center was founded with some groundbreaking propagation work from Professor Ted Rappaport, who was the founder of the center. At that time, people had never believed that millimeter wave communication could be used for long-range outdoor cellular links. Professor Rappaport's group proved them wrong. He took a number of measurements of hypothetical access points and deployed wireless transmitters where you would deploy base stations in downtown Manhattan, and showed that you could get connections 100, maybe even 200 meters from a potential low-power millimeter wave cell site. These were groundbreaking findings and ended up inspiring much of the work that we're seeing in millimeter wave today. Indeed, for example, the FCC cited this work as part of its initiative to open up the spectrum, and we've now seen the spectrum opened up. We've seen the 5G standards being designed around using the millimeter wave bands, and we've seen a huge amount of corporate work, and been including a lot of work at our industrial affiliates. Now, a lot of the wireless research and objectives that you've seen have focused on two key aspects of wireless, that is bandwidth and latency. Those, of course, are two of the pillars of, for example, the 5G vision for wireless. What's unique about the Cosmos platform is it adds a third dimension, which is compute. Because, of course, the key benefit of wireless today is to allow connectivity to strong computing engines. This will be key as we understand all the applications that wireless is going to be used for in the future, whether it's mobile edge computing, autonomous driving, cloud-based vision systems, and so on. So we really see this as three dimensions to explore with: compute, latency, and bandwidth. And we'll give a unique testbed to experiment with how these three interact with one another. The Cosmos program is really one of the most ambitious testbeds in U.S. universities today. It's going to be 20 blocks of wireless area covered in the northern Manhattan Columbia University area, and will compose around about 100 nodes. Many of those nodes will be equipped with the latest cellular and wireless LAN technology, importantly including fast fiber optic connections to those cell sites. There's really been nothing at this scale at a university level. Many of the industrial affiliates have, of course, demonstrated incredible 5G systems, but this will be one that's completely open source and able for both universities and industries to experiment with. Cosmos architecture has an innovative and very thorough platform to allow experimentation at all levels. At the lowest level is an advanced set of radio access nodes, which many of you are familiar with. These will include, for our purposes, both millimeter wave nodes, massive MIMO nodes, and other latest technologies. These are going to be completely software-defined, based on a software-defined radio platform, which will allow people to experiment with any of the components in those, including the digital signal processing, the antenna systems, and so on. After this, though, in addition to just the core wireless technology, it has a unique and completely programmable front-haul and backhaul infrastructure based on fiber optics expertise coming from the other partner universities, including Columbia and Rutgers. This will go, for example, fiber optic connectivity back to data centers that are located throughout the city. The final part of this is that located in these centers will be very strong compute nodes, racks of processors that we can place not just cloud RAN and rather RAN processing, but other applications that could run on networks in the future. Things like mobile edge computing, autonomous driving, and vision processing. All of these could be run on these powerful systems to look at wireless technologies from an end-to-end perspective. So NYU Wireless will be responsible in the millimeter wave components. We've had over 5 years of experience and pioneers in looking at millimeter wave for 5G, and we think we're very well poised to look at how millimeter wave and other advanced technologies will be used in the future.